All right, so SQL stands for Structured Query Language, SQL. So this is the language of the database. Over time, you have heard some words like RDMS, RDBMS, like Relational Database Management System. You have heard of MySQL, SQL Server. You have heard of Postgres, MariaDB, SQLite for those who quickly do the data web application design. You notice they always say this thing: go and store we store our data in a database. This database we're talking about, it's being controlled. The language you use to query or get data from this database, it's called SQL, Structured Query Language. And why do we use this SQL? Why do we have to learn SQL from the point of data to the point of software testers and developers? So, like we said, most languages, most data in the world, I can say over 60% of data in the world are in SQL, in a structure, so they are in a structured query language. In a relational database. Most data is stored in a structured database, in a relational database. So to be able to access that, you need SQL. Other truth about it is, because so many data is stored in this place, it becomes important that there becomes someone whose job is to protect this data, whose job is to give access role to people about this amazing data, because this data is a company's asset. So it becomes important that someone is involved, is there giving access to people. And it's also important that someone is there making sense out of this data, analyzing the data. Someone is also out there cleaning up this data. So because it has become a very valuable asset to the company, that's the reason why there need to be some persons who need to make sense, get meaning, and meaningful value out of the data, so that the company can make informed decisions from historical transactions they've been having over time. And there's also need for someone to test that this data that is inserted into this place is actually there. The data we already have is the same number as what we are expecting. There is also need to be someone to inspect that the data being taken from that system and analyzed is consistent with the number or size of data we have in the database. And this is where you come in as a software tester to help test this. You also come in as a data analyst to help analyze this data. There are some other positions like the data engineers, the machine learning engineer. These people use data. So data has become so valuable that we need it. And most of the data we use today is stored in a relational database system. To get them, you need SQL. That is the language. There is no other language. That is the language you use to get data, to manipulate data, transform data. That's the language that the relational database management system understands. All right, so let's move on. So it is a powerful and standardized programming language designed for managing and manipulating relational databases. SQL is a standardized, let me get this, is a standardized programming language used for managing and manipulating relational database. So when we say standardize, there is what we call ANSI. ANSI is the organization that helps standardize SQL. And ANSI stands for American National Standards Institution. They are the ones that helped standardize SQL and say, okay, different companies, you keep, having your own way of getting data through getting a relational data through some form of code or language. Let's have a standardized way of getting this thing. Let's have a standardized way of getting this thing. And that's why this organization came up and standardized the use of SQL. Now, the standardization we're talking about has to do with, let's have a general way of getting this. Yes, your own way will be working. Let's have a general way. All right. So we are in the UK. There is the standard English that's the world understands that it is correct English. But when you go to the northeastern part of the country, you hear an accent that is like a deviation from what the standard English is. When you move further to Scotland, you still get some stronger accents. When you come further to the south, it tends to kind of water down. So, but in all these things, we still have a standard way that we communicate, that everyone hears. And when that standard language is spoken, everyone listens to it. And that's how it is with SQL. And that's what we call it, we say standardized language. So, and when we talk about managing, we use this language to manage all the data in a relational database. And then, of course, manipulate them. So let's go back and talk about this standard, this ANSI. So this ANSI stands for American National Standards Institution. So it's the generic SQL. Now, in it, just like we have all the different part of the UK having their strong accent, we also have it in SQL. So we have T-SQL. T-SQL stands for Transactional SQL. And this is by Microsoft. And that is what you use to query. The server you use to query it is SQL Server. So, and it's owned by Microsoft. The next one is, so what it means is when you install a SQL Server and SSMS, the language we use to query, the official language to query data in that server, it's called to query data in that server is called T-SQL. Then we have, of course, we have the MySQL, which is also MySQL. And MySQL is owned by Oracle. We have the Postgres, which is also Postgres. So where you're going to see a little disparity, it's mostly here. The way we use it here, because these are the tools we're going to be using. So you will see the kind of differences that operate there. But understand that they have their own way of displaying SQL. However, they still obey some generic terms approved by, all generic terms approved by ANSI. And it is this same SQL that you also use to query BigQuery. I'm sure you have heard of BigQuery.
Yes.
Good. So BigQuery, thank you. BigQuery is Google's data warehouse. It is the same SQL you use to query BigQuery. So you're going to learn one technology that you can use that you can use in several places. It's the same query you will use for Synapse Analytics in Azure. It is the same query you will use for Redshift in AWS. You use it for AWS Athena. So just mention it. And let me tell you also, we also have, of all these things, you say this is owned by Oracle, but we also have Oracle too as a relational database. So on the general ground, it is still the same query you will use for Oracle, but Oracle also has its own, you know, unique, its own accents too. All right, so, and you can imagine an array of different places where data lies. And all these things, you just need to learn one language to be able to access them. And companies use all of them. Different companies use different technology. Some use SQL Server, some use MySQL, Postgres, BigQuery. Some actually use a combination of them because this is not a database. This one, these three are not database, they are data warehouse. So most companies will have a database and then maybe merge it with another one. So most companies that have data warehouse also have a relational database because mostly these three, you mostly house transactional data and this house analytic data. And we're going to come to that later. So that, in a nutshell, is a simple explanation of SQL. So let's move on. As I said, just one language, you can do amazing things across multiple technologies. They just come. All you need to do, how do you know to use know to use them, know to use BigQuery? So all you need to do, there are some uniqueness for amongst all of them. You just try and learn that little uniqueness that is not part of what we cover. So for instance, when you want to select the top 10, T-SQL will say it's top 10. But MySQL will say it's limited to 10. So you can see different flavor of the same language. So all you need to know, if you have learned this top 10, when you want to use MySQL, you just go and find out how to limit data query to the output to like the first 1,000. And then you just know that your search will just quickly tell you use limit, not stop. And that's how easy it is. So, and now this brings me to a very important skill you need. You see, learning how to make research is part of what what will make you stick. So I encourage you to learn how to make research. It's going to help you. Learn how to make research. It's going to help you. All right, let's move on. All right, so before we get there, I will also need to explain some terminologies. So in SQL, so in a database, in a relational database, like I told you, it is structured. All right, let me get my pen again. It is structured query language. It is structured. So what it means is it's represented in table format. They are just organized like this. That's what we mean by it is structured. Now, A single data, a single point, let's say this is name, and this is age. So the age is 17. My name is Kingsley. Kingsley here, it's a single data. Like in Excel, you could call it a cell. And this single data is called data value. It's called data value. So, and let's say this is a serial number. So a combination of this, one of this is data value. My age, just my age is also a data value. But a combination of data value gives us a record. And what is the combination of data value? Just everything around here, everything around here gives us a record. And can a record be just one data value? Yes. It could just be a list of names, a table of names only, and then one record will just be a data value. So a combination of this will be a data value. And I'm sure your guess is right when you ask, okay, does this mean the same thing as row? Yes, it means the same thing as row. A record is the same thing as row. All right. So when we have this, so if I put the second name as Francisca, and she is just 16, sweet 16. I put the third person as Fola, and Fola, forgive me, you are 60 years. Now, if I move this out, if I move the name column, the name out here, this is called a column, and it's also called a field. So a column is also called a field. Column is also called a field. So when you move higher in your data pursuit, it can also be called variable, which is what data machine learning engineers use more. So this is also called tuple. Just take note of those things. Now, so this is a column. It is also called a field and a tuple. A combination of a row and column gives us a table. So rows and column, or records and fields, gives us a table. And what is another name for table? Another name for table is called entity. Now these names are coming together. Another name for this can be called database objects. Database objects. Those are very important terminologies we use in the world of data. And now, when you have this data, this table of customers, and then in another, and you also have another table called sales. Perhaps you have another table called products. When these three tables are found, three or more tables find themselves organized in a database, we call that database relational database. When they are properly linked and communicate with each other, we call that table, database, relational database. So the combination of related tables, take note of that, in a database forms a relational database. A combination of a related table in a database forms relational database. Does that make sense? Are we good, guys?
Yes, we are.
All right. So let's move on.
Yes.
Now, thank you. Now, the main goal of a relational database is to organize huge amount of data sets for efficient retrieval. To organize huge amount of data sets for efficient retrieval. Efficient means being able to retrieve it as fast as possible without consuming compute power and too much compute power and too much space. That is what we're talking about, being efficient. Now, when you have this when you have this database and the relational related tables, we have what today you call, when we have this database with related table, we have what you call RDBS, relational database system or relational database system. Now, when we have them,
Please, can you say it again?
when we have a combination of a database and related table, we have relational database system. A combination of database and related table, not just any table, related table, like tables that are properly linked together, we have relational database system. Now, a combination, when we have this relational database inside, when we move this related database inside a place called, so to query this database, you need a nice interface. And this is where we have RDMS, Relational Database Management System. Use this to query this properly. You can actually query your data without this using the normal command prompt. But who wants to do that? So this helps you analyze your data, retrieve your data, create database, do a whole lot of things. This plus this gives us this. Remember what gave us this? A combination of this table plus this table will give us related table. A combination of this in a database is a relational database. And the combination of the database and the related table is called relational database system. And this can be queried in a relational database management system like Workbench, SSMS, PG admin 4. PG admin 4 is for Postgres, SSMS is for SQL Server, Workbench is for MySQL. Do you have any question, guys? Any question? Oh, amazing.
Not for me.
Okay, we are doing great. No question. Okay. All right, so let's move on. Remind me, please. So I'm going to use the concept of procedural to explain declarative. As we said, this is declarative means non-procedural. All right, so look at this. If you check the message I sent you guys about how to register. All right, so Valentine, please ask your question.
Sorry, that was a mistake.
All right, so let's move on. So when you're registering, it is easy to tell you, go to PrimeSoft website. Click on register. Register. Select your course. Select your course. Click on enroll. Click on enroll here. Fill in your details. Click submit. You know how you say you want to write it in acceptance criteria. So let's count 1, 2, 3, 4, 5, 6. So in 6 steps, you will register in PrimeSoft on PrimeSoft website. This step-by-step approach of trying to achieve a thing is known as procedural programming. Step-by-step approach of trying to achieve a thing. But you know what? In declarative programming, where it will go, it will tell you go to PrimeSoft website, go to PrimeSoft and register. This is just one step. And this is declarative. Which method do you like?
Procedural now.
Procedural programming.
You like procedural, isn't it?
Yeah.
Well, Unfortunately, I have to disappoint you. So what really happened here is procedural programming has in this one line of code, it has in it it's embedded all these remaining 5 lines, sorry, into it. All it just needs to do, you just tell it what to do. Just do this. And it knows that it means go through all these steps and do it. You don't need to give it details. And that is where SQL falls.
Really?
Yes, really. So let's move on. So in procedural programming, in declarative programming, it becomes easy to just tell it, give me all the table from all the columns from this table. That's it. It will just give it to you. But in normal programming, in normal procedural programming, it will say, go to this place, do this, do that. If this happens, don't do this. Then provide me with all this data that I need. No, SQL does it, just goes and do that. So and do what you need to do. And then on the other side, to now make it much more powerful, to do more things that you would want to do on a custom level or a personal level, it also has the ability to perform procedural programming and even functional programming. And the functional programming part is called stored procedure. It has the ability to also perform procedural programming, but that's not the main job. The main thing is declarative programming. Does that make sense? Yes, it makes sense.
Yes, she does.
And if you have questions, please ask.
Sorry, I don't understand the aspect you said that SQL can also function under functional programming.
Yes, so that is what we call stored procedure. So stored procedure are more like just functions that you create. They are reusable code. Reusable code, because that's what function is. Function is just a chunk of code that you can reuse whenever you want to use it. So you can create stored procedure, keep it somewhere anytime you want to. For a particular query you do all the time, you create a stored procedure. That is the right thing. Keep it there, especially when the code takes time for you to create. So you don't go and trash it. When you're done querying the table, you then stop. No, you store it as stored procedure so that whenever you need it, you run it, and then it will provide you with the latest information you need in line with the information, the instructions you give to it. So that functional part of it is called stored procedure.
Okay, it's clear now.
All right. Stored procedures are not something you do all the time, but trust me, they help a lot. They help a lot. Almost all companies do it, but because it's not something you do all the time, it's dependent on the normal select statement. However, by the time you just see it as one big thing you have done, and when you have done it, you have achieved it. As you have achieved it, the next you store it somewhere. It's a project. So see it as if, as a software developer, you have been able to build a login system, a login for a particular application. So that's how you see it. Anytime, any day, you see that piece of code you used to build that login, you can actually reuse it for another person. And that is what we call modularized kind of a pattern of coding. And that's what object-oriented programming comes in there, an MVC method. But that's not what we're talking about now. So let's move on. Let's talk about some interesting syntax in SQL. All right. So, like I said, SQL is a declarative language, and it is a language of the database. And you and I know that for it to be a language of the database, there need to be some set rules that need to govern it. There need to be some set of rules that will help you know what to get and what not to get. And we are going to go through all of them. There are four major ways, four major controls or I'll call sections of syntax in SQL. So the first one is DDL. I'm sure you have heard of it. This is one of those things that come out to an interview. Anytime, any day, SQL interview, when they want to ask you verbal SQL interview. So this is some of the things that come out from it. So DDL, data definition language. And what is DDL? So DDL is simply a set of statements that allows the user or you to define or modify data structure and objects. I told you what a data object means, like a table. Tables are data objects. So a set of statements that allows you to modify or define a data object or data structure. That is DDL. And the first DDL we have here is to create. And it's so simple. That's one of the most used one out there. It's as simple as saying create. We're not going to syntax into the normal syntax today until we start creating, we start manipulating data. Create database. And you name the database sales. That's how simple it is. Use the statement create. What do you want to create? Database. And you name and you say what you want to create. It's at the name of the database table sales. The same way, create table. You mention the table. Of course, you know table, you cannot create the table without the columns. You mention the column names and it will create it. And that's what the create statement is. It's used for creating database objects and tables as well. That's what create is. And it is part of data definition language. It is used to define data. All right, the next one is the alter. So what is alter? The alter is used to add, remove, and rename an existing object. That's what alter is. So it's used to add, rename, and an existing object. That's what the alter is. So, use it to alter, to change a thing, an existing table. That's what alter is. And you don't always use it. So as data professionals, you don't always use it. As QAs, you're never gonna use it, but just understand what it does. Drop. All right. Drop is used to completely delete a database or its object table. And what do I tell people? Don't. As data professional, don't ever use drop. Don't ever use drop. And that's my sincere advice. I use it to delete a view I didn't know, because I named the view the same thing I named the same name with the table. I actually use it to drop a table. And it's as simple as drop table, you put the table name. And I started.
So you can't retrieve it. Is there no way to retrieve?
Let us continue first. Continue. So the next one is truncates. And what do you use truncate for? It helps to remove so let's say you have so many tables, data in a table. So and you have some data in here. So the truncate will remove all the data, will help you remove all the data, all the records in the data. That's what truncate does. So if you want to empty your table, it's not going to delete the table. It's only going to empty your table. So truncate is used to completely delete a database. Truncate is used to, it helps to remove an entire data in a table without deleting the table. That's what truncate does. And then rename is used to just rename rename something in a database, like table name, column name. That's what rename is used for. And when you look at this, look at what it says, definition. So you used to define something, you used to change something, which is also around the creation, definition, defining something. This is used to drop, drop what you have defined. This is used to truncate, clear what you have defined, and renaming. So, and these 5 fall in data definition language, the word DDL. As data professionals or data analysts, most importantly, or will not use this at all. Can do it, use it for practice, but you can hardly use these queries. So I would not recommend, especially this. I would not even recommend you to start practicing with your with the company's data with this. Please don't. All right. So here comes where we will be dwelling most of our time in SQL. Data manipulation language, DML. Data manipulation language. And what is this? So the data manipulation language allows you to manipulate, that's the word, the data in the table of a database or tables of a database. Data manipulation language helps you to manipulate, that is the key word there, manipulate data in a table or in a data in table or tables of a database. So we have 4 main statements that we use for this particular type of language. The first is select, which we are going, in fact, we will use almost every query we want. Like, not almost actually. Actually, every query we want to, as long as you want to get something from table, you have to use select. You have to use select. So select is used to get data or get data from a table or group of tables. That's what select is used for. And you will use it a lot. It's used to retrieve data from the database object, which is table. The next is insert. Insert is used to insert data. So you want to add, you have created an empty table. You have created an empty table. You can use insert to add data into the table. That's what it does. And then you have, the next is update. So you have updated you're done creating your data and you made mistake in your name. So you can go there and update your name. But update should go always at all time with where clause. Never ever try to delete. Never ever try to do this without using where clause. you're going to, so what will happen is you will, if you want to change your name and you didn't use where clause, it will go and change every record in that database, in that table, to your name, to the new name you want to update. So everything will just be Fola.
Sorry, you said wear gloves. Wear gloves. Where are we wearing gloves?
Where
Which
clause.
one be where?
Where clause.
I thought I had wear gloves.
That's what you had.
Oh,
That's
wear gloves.
what I
Update.
said.
Okay, wear gloves. I thought I had wear gloves.
Okay.
So update is used to
Update your information on the data, on the table in a database.
if there's a mistake that you want to correct,
Yes.
right?
But please don't go and update company's
Okay.
data.
Is it used for just tables or just any
It's
kind of
tables.
data at all? Just tables.
Yes, you need to update data in a table.
Okay.
All right. So the other one, the almighty one, is delete. So it also works like where it does not. You need to put where, otherwise you delete everything. So what does this mean? There's always an identifier, especially a primary key. So if Lola's number is 10, you will tell it go and update Lola, which we mistakenly spelled Lolo. Go and update it to Lola. You will need to tell it where the name, the ID is equal to 10. It will come to this place and then update this. You don't put where clause, it will update, it will mess it up. It will change everything to Lola. If you still want to delete the same thing, if you don't put where clause, it will delete everything from the table. All right, so let's move on. However, there is a time.
Sorry, Kingsley. So delete. You said delete is to delete a record. Is that correct? I just want to know the difference between delete and truncate.
Yes, delete is there to delete a record at a time or group of records. Like
Okay.
you want to delete your name and your last name, you just choose your numbers and delete it. But truncate says you want to empty that table. So that is a difference. Completely empty table is a difference. But if you then decide not to use your where clause, then your delete will turn to truncate. But this cannot work without where clause if you enforce data integrity through relationships. We're going to test it. We're going to apply it. And that is one of the things the QAs will test. And what are they going to test? Let me demonstrate it here. Let me explain it here. So let's say we have sales or order table. This is the order table. So, and this is like order ID. This is the product you want to order. This is sales. So like amount. So I will mention this like 10 pounds. I will say the name is pizza. Then the ID is 6. Now, if we have another table called products that has a product ID, and then the product name. All right, so that means this place, the product ID here, I'll just, since my number, this looks like 12. I'll say the product name, the product we are ordering in this order, the ID is 12. But the name here, we have pizza. Then we have product number to be 12 or product ID to be 12. So if you go, assuming we also have another one that is the name so that it's easier to know. So if you go and use your delete clause, your delete statements to delete, go to other table, delete, go to other table, delete everything, like delete this row or delete name, delete this row where, because when you want to delete, you're actually deleting an entire row, where the ID is equal to 10. Go and delete where the ID is equal to 10. This will not delete so easily. The reason is because, oh, sorry, when you come here, it's on this side, sorry. When you come to this product table and say, please come here, delete pizza. We no longer sell pizza in this company. Please delete pizza from our, product table. When you come here and run this query to delete, it will not delete. Do you know why?
Is it because it's in another table?
Yes, because it is in another table. So because this particular data is being referenced in another table. So what it means is when you delete it here, it will delete here too. So it will not delete because something is here, because it is here. And this is what we call referential integrity. So that way, when you try this, when you try to delete, you will find difficult to be able to delete. But this usually works in a relational database. And that helps in the referential integrity. Which one we'll talk about data management? I think we were going to go through it. All right, so we're done with DML, a very important part of what we are doing. So the last two, it's not within in fact, you don't do this, but it's important to know it. So let's say you are the database admin, DBA, that's what they call it, database admin, or anybody can be that. You are in charge of this database. You are managing this database. So a new data analyst comes. And this data set has several data sets, but you are a data analyst who was employed to be in charge of analyzing sales data. Sales data. DBA will come and grant you permission to access only sales table. Sales table and any related table in sales table. That is what the DBA will do. The ability to give you access to this sales table, or what you can do, DBA can also say the only thing you can do is to select. DBA can give you this level of assets that you can only select data from here, from this table. So that means if you try to delete, you won't be able to delete. You try to insert, add data, you won't be able to add. If you try to delete, you won't be able to. If you try to update, you won't be able to update. And that is what data control language is about. Does that make sense, guys?
Yes. Oh, why do you say we will not? Because some of us may actually end up being database administrators. So what do you think?
Oh, amazing. So if you are a database administrator, you will be in charge of giving access to these people. So like I said, so you are employed as a sales analyst or a data analyst, but you're in charge of your access is only to this, to sales data. The DBA will give you access to the database, most likely, but you only have access to sales data. He will give you access to sales data, and he will tell you, he will put such access such that he can tell you, okay, you can only do sell, you can only do select, because you don't have business doing insert, update, or delete, because that comes from the application that brings in the data. The DBA could say, okay, all right, you have access to sales, and I also give you access to do everything here. And you're coming in as a data analyst who is in charge of HR data. So you could be like a HR analyst. HR analyst. To give you only access to employee data, and then you have access to only employee tables and the tables that relate to employee. You don't know anything about sales. You don't know anything about finance. This DBA grants this access, and DBA revokes the access. Revoke is the opposite of grant. Grant is to give you the access to it. Then revoke is to take away the access from it, or all or some of the access given to you, or permission given to you. Does that make sense, guys?
Yes, it does.
Okay. So let's move on. The last one here is transaction control language, TCL. So when you have done changes, so you have said, when you have, let's say you have different persons who have access to the database. So as a DBA, you who has access to do permission to do everything. So you actually went to other table and eventually finally remove this with code. You drop this column, this row. When you drop this row and move on, this salesperson will not see that row effect. It will not affect. The effect will not show. You will not, this person will not see it. Because that particular statement was not saved. To be able to save it, after writing your query, you need to write under it, you put commit. That will save your data. And then the other people that have access to it will be able to see that changes, or the update you have made, or the delete. Then to undo that particular thing, when you have not saved it, when you have not committed it, you roll back. So roll back will help you go a step backwards into where you are. So roll back was what I used to be able to get back my data that I dropped here. Now, Francisca, did it answer your question?
Yes, it does. But
Don't try it.
so what you're saying is that as a data analyst, you can still use rollback. It's not only database administrators that use
What I am
rollback.
saying is, as a data analyst, you don't have business with rollback as long as you don't go and drop people's table, company's table.
I know, but in case you find yourself there.
Yeah, as long as you do not use commit, you can use rollback immediately, not later. Use commit immediately, use rollback, it will be able to roll back the data. Actually use it. It worked for me. But don't try this. Never, ever use drop.
Okay.
Never, ever use drop, please. All right. Do we have any other question here?
So what if you actually want to delete? Like you don't want that database anymore or a table anymore.
So it is not your job to even create database for a company. Does that make sense? Except you are a DBA. But if you're a data analyst, it is not your job. And there's actually nothing wrong in being a DBA. After this course, all you need to do is to take a few hours more course. You can be a DBA. Trust me. I can assure you 100% you can be a DBA after taking this SQL course. So if you want to delete a data, of course, you must have been absolutely sure you want to delete a row from your data. You go and use delete. You want to completely clear a table and start all over, you come and use truncate. You want to entirely drop the table, you use drop. It works. Or you have to be in charge to be able to do that. And guys, that is what we call taking responsibility. Please, I beg of you, at workplace, don't ever deny something you have done. Take responsibility, especially being in the world of IT. However it is, they will go back to the transactions. The some of the transactions and check the records, and they will still be able to find out that it is you. Even if they are not able to find out that it is you, intuition could also point towards you. So learn to take responsibility for anything you did wrong. That's maturity. Mind you, the worst case scenario, it's going to cost you your job, but it's going to make you better. Trust me. But it doesn't always cost you your job. Not always. And especially if you can revert that situation, or it does not cause so much damage to the company. So learn to take responsibility, but don't go and delete data. Don't go and delete. Please, I beg of you. All right, so that is it. Do you have any question?
So this data control language, the grant and revoke, they are what the IT guys use in let's I used to work as a customer service officer in one of the banks. So this is what they use. I just want to be sure is what they use in either granting or not
Yeah,
granting
that's
particular, maybe granting access to I don't know, some menus on the system that allows either your line supervisor or whatever to be able to access that, whereby we cannot access it.
oh,
So
okay.
it's
No,
not
that one
so
it's not data control language. That one is what we call authorization in software development. These are just some kind of buttons that they will click, and then it will give you access to what they want to give you access. It's called authorization. That one is a software development stuff. But what we're talking about here is completely database.
okay.
Any other questions, guys? All right, so let's push. So notice we have 25, product description number 25, 25 here, 25 here. So look at it from this perspective, where Francisca goes to a think of. Francisca goes to Aldi, even though Aldi is not close to her. To Aldi in the morning, 7 a.m., and she buys. She buys grocery and what 70 pounds she returns. She goes, okay, I forgot some things. She goes around 2 p.m. She buys baby stuffs and she returns, and that costs her 30 pounds. So when she returned back, she noticed that she did not buy some other foodstuff. She went back, she bought more grocery for another 15 pounds. So you notice here that this is the same person, Francisca, 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 that bought grocery, grocery, and then, of course, baby stuff. When you look at this, you notice that this data is repeated, repeated, repeated. This is repeated, and this is repeated. Can you see that, guys?
Yes.
Yes, we can see.
This repetition of data in a table is what we call redundancy. Redundancy. So you have heard of the word, we need to remove redundant data. This is what it means. We need to get rid of redundant data. This repetition is redundant, repeating Francisca name all the time. Sorry about that. So, and that is what really happens in most data, in most tables you see. So if we look at this 25, okay, I don't see 25 here. Let's look at another this thing. So we don't find another one that repeats here. But see 7 represents product 7. So obviously 25 represents product 25. Notice it is just number. So compare this. Product 25. Compare how many characters. 25. Compare what it means. Compare it to product 25. How many characters? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's like 7 more characters than this. So to reduce redundancy, instead of typing products over and over again, product this, product that, product this, you just give them their name, just give them their ID, their index. Are you guys with me? Give them their index, represent that index in, create another table called product table, represent that index on that product table to mean those products, then remove the product name completely from the transactional table or the sales table and give it only ID. So this ID makes it easy. This ID makes it easy to, it helps reduce the amount of data you want to store in this data, on this table. Imagine all the repetition of product, product, product on all the rows. And this could span up to for a few thousand, it's nothing. But when it goes up to millions, billions of rows, it begins to be a huge problem. And that is why to reduce redundancy, we normalize data. So the normalization of data is a way to make a long table, break down a large table, a wide table, like table that has so many columns, into different tables, and then link them together. That's what we call normalization of data. So, having created a new table called column, we need to find a way for them to communicate. And before you can communicate, if you notice, there is this index here called 1, 2, 3, 4. This index, it's a unique identifier. These index numbers are unique identifier for each of the products. So this product's name, product 1 is called 1. Product 2 is called 2. That is the index. That is the unique identifier. And this unique identifier, it's called primary key. It uniquely identifies a row or an entry or a record in a table. That's what primary key is. Uniquely identify a record in a table. Does that make sense? Does that make sense, guys?
Please come again with the division of the primary key.
So you see how these numbers are uniquely identify each product. You can see nothing is repeated. Let's check the sales table. See the other table. See the other number. Can you see how unique they are? No one is repeated. These numbers that uniquely identifies each entry or each record in a table, it's called primary key. So if I want to know a particular row, uniquely know a particular row, I will need to query it by its primary key. Make sense?
Yes.
It uniquely identifies a row. So remember, it is a column. The value whose value exists and is unique. Another thing, when you're creating a table, when you're adding entry, if you're using code to add entry, when you are creating the table and the columns, primary key columns cannot be empty. Please take note. Primary key columns cannot be empty. So you must ensure that you must something there. That's because it uniquely identifies the table. So when this primary key is found in another table, this is a primary key. It's index. It can be called anything, but it's called index here. And it is found, it travels to another table, and it calls itself product description key or product description. When it finds itself in another table, it is called foreign key. It is primary key on its own table. When it finds itself in another table, it is called foreign key. And what is the role of foreign key? The foreign key is used to identify relationship between tables. So immediately you see it as product description key, you know that that belongs to product table. Does that make sense?
Yes.
So because you know that this thing is coming from product table and it is a foreign key here, you then know that it is definitely a primary key in products table. And with this, you can use your SQL to join these two tables together and get data from both tables. Any question?
Not from me.
Please ask question. This is very important.
So is it because of the word product that makes it a foreign key in this other table?
All right, it is not because of the word product. It could be another thing, another name. I have been in that situation where the names don't really match. The names don't relate, but that's actually the key. So you need to, or that's where understanding the data set comes to play. You need to understand the data set. But most times, these names are there. The names are related. So they use relatable names. So that's a product table. So this will be a product ID, product something. So the names are usually related. And if they are not, and you find out that that's actually the key, you name it, you rename it properly in your data set, especially in Power BI.
So are you saying that this product description in the second table is the same thing as the product name in the first table?
It's the same thing as what?
The product description in the second table is the same thing as the product name in the first table.
No, I didn't say it's product name. I said it's product index. You see it? Can you see how I mark
Okay,
it?
product, yeah, okay, product index.
Yeah,
But this one says product description here.
yeah,
So are you saying they are the same thing?
they are. They are the same thing, sir.
Okay.
So this product description where we have 27 means product 27.
Yeah, means product 27. You got it.
Okay.
And that's how it communicates with the main table. So going back to the redundancy, so what happens is, having created this table called product table, you would then create the names of all the products, and we create them once, we don't repeat. We create them once, and then only reference them with a number here. That way, we don't get to keep, repeating the number over and over again. Imagine 1 million transactions in a week from Amazon to buy a lawnmower. And on that your transaction table, other table, the lawnmower is a name there. Imagine you just have 1 million lawnmower. That's too much space taken and waste of space. And remember what we talked about efficiency. So when we have efficiency, we talk about speed, and you need to have a system that is fast and takes less memory in space. And then we also talk about optimization. So when you have that system that does not take much, that takes much memory in space, you have to work on optimizing it. And this is one of the ways to optimize it. So in a normalized table, in a normal table, like the transactional table, that's what we're doing now. We normalize data, we break them into different tables. And that is what we are doing with the database we want to create. We have so many tables. You could see them there. Do you have any other question?
No, don't have question.
All right, so we are doing good. All right, so I will soon release you guys. All right. So here I have 4 tables. So let us talk about them. Remember this transactional table, this other table down? Remember this one, products table? So let's talk about them. Having understood the foreign key and the primary key, so let's see how this table is done. So this one is the primary key. Can you guys tell me what the primary key will be on the, and this is the products table. We said this is this order table. You can call it sales. This is, you can see, it's easy, customer table. And then this one is the territory or the region, whatever you call it. So let's do something. Can someone tell me what could be the primary key on customer table?
The index, customer index.
Exactly. The customer index will be the primary key. Thank you, Lola. How about the region? What about the region, guys?
The index.
Index.
The index is the primary key. Good job. So mind you, it's not always written in this. But you know that that's the unique identifier. You see Australia is repeated here. Let me see what is repeated here. I can't find the city that is repeated here. Can't find the city. New South Wales is repeated here. All right, so now let's talk about them. Let's look for, can you look for customer foreign key? Customer foreign key, where it is? Can you look, get me foreign key from customer?
Customer.
As a customer's name.
There is no foreign
All right, so I agree.
key there. It's just two columns now.
Yeah, this is the foreign key, customer's name. Remember, I said it does not always bear the normal name. Oops. Already done this one. Say it is here. Can you tell me for the city? Region or city? Can you tell me for region, please?
Is it delivery region?
Exactly. All right, but done mapping. If I want to know what is in this table from here, if I want product to communicate with customer, product will pass through order and communicate with customer. I want to know all my customers and their region only. Region, customer table will pass through read order and communicate with customer with region. Right now there is relationship. Question? Any question? We're almost done. No question. Good.
No question from me.
So does it mean we have to create another table using these relationships we have in the mapping you did?
Another I don't understand you. Can you ask your question again?
Are we now supposed to create another table showcasing this relationship with the mapping you just did?
No, I'm just using it as sample. We are going to create the normal table we want to create.
Okay.
All right. I've explained foreign key, primary key, and relationship type. Do we have any question? That ends our class for today.